All right, so here we go. So this material contains information which is proprietary to and copyrighted by the International Code Council. The information copyrighted by the International Code Council has been obtained and reproduced with permission. The acronym ICC and the ICC logo are trademarks and service marks of ICC, all rights reserved. So my agenda for today will be to go through the different sections of the 2020 Energy Code. I've got all the sections listed here. So I'm going to do a brief overview of all of these sections. There will be information that I have to leave out as this is only an hour-long presentation, but hopefully this is a good overview. So the first chapter of the code is Scope and Administration. The effective date of the Commercial Energy Code was September 1st of 2020. So any project that had applied for or obtained building permits before September 1st of 2020 could still be applicable to use the previous version of the Energy Code, the 2015 code. And if any permits were obtained or applied for after that date, then you would need to use this code, the 2020. And in this context, the permit is a building permit or an Act 250 permit. Stretch code, there is no stretch code or stretch guidelines for the 2020 Energy Code as there was in the previous version. So when it comes to the code, that means that Act 250 commercial projects only need to follow the standard 2020 Energy Code requirements. If you have a mixed use occupancy building that is 3 stories in height or less, then any residential areas like living spaces, hallways, laundry rooms, those would need to follow the residential building code requirements, and areas that are serving either commercial or both commercial and residential would need to follow the commercial energy requirements. And any building that is 4 stories or more in height, all of the commercial energy code requirements would apply. Code official and enforcement. There is no official code official designated in the current code language. It does state that the Vermont Department of Public Service does not enforce the code, and I also want to reiterate that Efficiency Vermont does not enforce the energy code. So moving on to the second chapter of the code, there's a bunch of definitions. I've included just a few of the what I think are the most important ones. So this is cold climate heat pump. They're defining as air sourced with a variable capacity compressor. It's capable of full heating capacity at 5-degree outdoor air temperature while maintaining a efficiency of 1.75 COP. And that rating is with a specific matched indoor and outdoor unit from AHRI. That's who rates the equipment. There are numerous building occupancy types that come into play later in the code. I'll go through these here. We've got assembly type buildings, Group A. Group B are businesses. E is educational facilities. F is factory and manufacturing. You've got institutional buildings. You got merchandise sales buildings, storage type buildings. And Group R are residential type commercial buildings where you've got R1 are hotels and motels, R2 is apartments, dorms, and so forth. R4 are supervised residential care facilities, and R3 is anything else that hasn't been listed. On-site renewable energy has been defined as energy coming from these different sources: solar, wind, landfill, gas, biomass, which is wood, and geothermal sources. And semi-conditioned space. So this is an enclosed space within a building that is heated or cooled, and the heating output for that space would be less than or equal to 14 BTU per hour per square foot, and the cooling output would be less than 3.4 BTU per hour per square foot of floor area. So those are pretty low standards, and you'll see coming up where that comes into play. So the next section of the code, diving into the details, we've got the building envelope requirements. Overview of the changes. So there's the new definition that I just stated, the semi-conditioned space. There are updated U factor and R value tables. There are new assembly U factor reference tables, which are good to keep in mind. And window and skylight efficiencies have changed slightly. And there are updated air leakage requirements for commercial buildings. So these are the new roof insulation required levels. And as you can see here, there's a requirement for a fully conditioned building and any semi-conditioned space also, which is a little more than half the requirement of a fully conditioned building. So again, I want to reiterate that semi-conditioned is pretty low energy use. So all buildings that are heated or cooled for typical occupant comfort will still be in the conditioned space. And the insulation values are a bit closer for all different roof types compared to the old code. If you're using continuous insulation, you need to use at least 2 layers of insulation and have the edges staggered. You must have at least R12 over the entire roof deck, and the value from the previous table is the area weighted R value of your entire roof, depending on if you've got less or more in certain areas. And if you have tapered insulation near roof drains, you have to maintain at least 60% of the R value of that table at the roof drains. Mechanical curbs need to be insulated to R12 and skylight curbs to R10. Above grade walls. Again, you've got the conditioned and semi-conditioned requirements here. These are different R values that should get you to the performance required. And one thing to mention here is that continuous insulation is a requirement for all the different conditioned wall types. So some amount of continuous insulation should be required on all above grade walls. For below grade walls, these are the R values, R15 continuous for conditioned and R7.5 for semi-conditioned. For floor insulation, these are the different values. What I will point out as being the biggest change is for a conditioned space, both unheated and heated slabs now require insulation under the entire slab and not just around the perimeter, as you could do previously with an unheated slab. So now there needs to be insulation under the whole slab. Windows and skylights, these are the updated window U factor and skylight U factor and solar heat gain coefficients. The maximum window to wall ratio is 30% for above grade walls, and for skylights, it's about 3% of the roof area. And skylights are required for spaces or above spaces of 2,500 square feet or more with at least a 15-foot ceiling height. There's some exceptions in there, but that's the general rule. So the new air barrier requirements are, you've got two options. You can either do performance testing with a blower door and hit a specific number, or you can do air barrier commissioning where you do not need to hit a specific number, but there's a large checklist in the code book that you need to follow. So the air barriers need, if you're doing the testing route, you must meet or exceed 0.30 CFM per square foot, and that is at 75 pascals of depressurization. That used to be 50 pascals in the previous code, and the square footage calculation is with a 6-sided envelope. So you're now including the area of the slab and below grade walls as well. And if you've got a large 50,000 square foot or more building, you're only required to test a portion of that building, not the entire area. There's a new addition for individual dwelling units. So individual dwelling units must be tested and hit an air infiltration mark of 0.35 CFM per square foot. Again, that's at 75 Pascal pressure, and you're calculating using all 6 sides of that dwelling unit. So you must test a random sampling of units. It's about 10% of the units in a building, and the construction contractor will not be the one choosing the units. They'll be randomly selected. And if a dwelling unit fails the air infiltration testing, then it must be repaired and retested until it passes. You cannot have any dwelling units fail that test. And during the test, HVAC systems will be shut off, but there will be no taping or wrapping put around the HVAC vents or louvers in the dwelling unit. So that's all for the basic envelope requirements. There's obviously more tables and values in the code, but that's the general overview. I'm going to move on to mechanical systems unless I hear of any questions leading up to this.
Nope, we're all set. Thank you.
All right, thanks. So building mechanical systems. This is an overview of some of the changes I'll discuss. There is an electric resistance backup heating allowance when you have cold climate heat pumps. HVAC performance, the equipment, the tables have been updated. Energy recovery systems, there's been changes, economizers, parking garage ventilation, and VFDs on fan systems. So there's a ventilation requirement stating that ASHRAE standard 62.1 version 2016, which is the standard for ventilation for acceptable indoor air quality, must be followed. And that version of standard 62.1 states that natural ventilation is no longer allowed. You must have mechanical ventilation in all new commercial buildings. That's basically what this slide is summarizing. So electric resistance allowance. So overall electric resistance heating is still prohibited in Vermont for all commercial buildings, but there are 2 new exceptions here. One is for multifamily buildings when you meet a heat load requirement that is quite stringent of 6 BTU per hour per square foot at design temperature. So if you can show that the building has a that low of a heating load, then you can use electric resistance to heat that multifamily building. And if you're building a commercial building where you're using cold climate heat pumps, if the full heating load can be met down to 5 degrees and you have a cutoff control of that electric resistance heating above 5 degrees, you can use it as long as the air, the envelope is tighter than standard. So if you can test and meet 0.20 CFM per square foot at 75 pascals and 6-sided, then you can use electric resistance below that 5 degree mark for heating. and I've got an asterisk here. If it's in Burlington, Burlington, you have to get BED approval for both of these exceptions. HVAC equipment performance. So there are, I think, 12 different tables in the code book where you've got efficiencies for air conditioning, condensing units, heat pumps, water chilling packages, VRFs, and boilers and furnaces. This is a just quick snapshot of the boiler section. Overall, it's actually pretty, the numbers are pretty close to the previous version of the code. So I didn't go through and break that all down, but those tables are in the new code. This is not specifically in the code, but I think it's a helpful definition to have of a fan system. So the fan system is the heating and cooling source. So it's actually where the heating or cooling is being transferred to the air that's then being sent into the space. So an example of small single zone fan systems would be a VRF system, each water source heat pump, a fan coil unit, or a small rooftop unit. And if you've got larger multi-zone areas, then your fan system's likely to be the entire large rooftop unit or air handler, wherever the heat is being transferred to the air and then passed into the space. So, and this matters for in the code for certain aspects, including the economizer and energy recovery systems. So economizers are required on cooling systems of certain capacities, so chilled water systems, so water-cooled chilled water systems over 110 tons need economizers, or air-cooled or district systems over 143 tons need economizers. And individual fan systems, so that's the definition I just described, with capacities over 4.5 tons need to have economizers. So that's a fair number of systems that we'd see in Vermont. There's a few exceptions. So if spaces have certain humidity set points and needs, then you don't need economizer. If the systems are operating less than 20 hours a week, or you have heat recovery included, then you do not need to have an economizer. So CO2-based demand control ventilation is required in areas that are 500 square feet or larger, and they have an occupant load of 25 people per 1,000 square feet or more, and also have one of the following systems, an air side economizer, modulating outdoor air dampers, or a design outdoor airflow rate of 3,000 CFM or greater. Those spaces would need demand control ventilation. And again, there's some exceptions to this. If energy recovery is included in that space, or there are no DDC controls, or it's only process-related ventilation, you would not need to include demand control ventilation in that space. Parking garages. So an enclosed parking garage is one that has either 0 or 40% openings within it. And there are, you must follow the Vermont Fire and Building Safety Code ventilation rates, which requires continuous ventilation of 0.05 CFM per square foot. And that ventilation system must be able to ramp up to 0.75 CFM per square foot. And the fan airflow rate will be based on carbon monoxide sensors that, based on different levels, it'll ramp the speed of the ventilation fans up or down. Energy recovery systems. So the language in here has been changed away from that fan system definition that I described earlier to air systems. The effectiveness of energy recovery systems must be 50% effectiveness. Spaces where you don't need it are heated to less than 60 degrees, operated less than 20 hours a week, if you're exhausting any toxic fumes, any kitchen hoods that have really grease-laden air, or this is a new exception, if 60% of the heating energy is provided from site recovered energy, then you would not need energy recovery systems. So this is the table from the code showing what percent outdoor air rate and design airflow speeds require energy recovery. So any system operating more than 3,000 hours a year would use this table to figure out if they need energy recovery or not. I think it's easiest to use an example to go through this. So the example I'll describe is a rooftop unit that has a 10,000 CFM design airflow rate, and it's operating 4,000 hours a year. If its outdoor airflow rate is, say, 3,000 CFM, that means it's operating at 30% outdoor air. So if you go to the table and look at the third column, you've got between 30 and 40% outdoor air at design. So that's what this rooftop unit would fall under. And then you go down to see what the total, if you are greater than or equal to 5,500 CFM of total design airflow, you would need energy recovery. This is a 10,000 CFM rooftop unit, so therefore this an energy recovery system would be required for this rooftop unit. Kitchen exhaust. So if a commercial kitchen has a total of exhaust of 5,000 CFM or greater, then you would need, you're required to put a demand control ventilation system on the kitchen exhaust, where you can reduce the fan speed to at least 50% flow, and you have to make sure that at least 75% of all the kitchen exhaust airflow is being operated by that demand control system. Hotel and motel HVAC controls. So any hotel motel with 50 or more guest rooms must have temperature setbacks and ventilation system shutoff based on occupancy controls. So after 30 minutes of unoccupancy, those systems, the temperatures will be set back and the ventilation systems would shut off automatically. Fan speed control. So VFDs are required on fan systems that are 2 horsepower or greater, and heat rejection devices need to be able to reduce their airflow down to 50% of the design. And at that, they'd be using 30% of the rated fan wattage. Duct and piping insulation. So duct insulation is the same in this version of the code. It's R8 in plenums within the building and R12 on any ducts outside of the building envelope. And for pipe insulation, it's pretty similar. The only temperature range that you would not need insulation on pipes is between 60 and 85 Fahrenheit. Outside of those ranges, whether it's cold or hot, you would need some amount of insulation based on the fluid temperature and the size of the piping that you're insulating. So that is all I had for this overview of the mechanical system. I will pause quickly for questions, and if not, I'll move on.
Nope. Looks like we're set for this section. Thank you.
All right. Thanks, Bryn. So moving on to the next one. This is a pretty short section, but for domestic hot water, service water heating. For electric water heaters, the maximum size of the electric resistance unit has been increased from 5 kilowatts up to 7.5 kilowatts. And if you have a hybrid heat pump water heater that has supplemental electric, there is no limit to the size of that supplemental electric heater if at least 60% of the hot water demand can be met just from the heat pump portion alone. And if you've got any showers in that building, they must be 2 gallons per minute or less flow shower heads. And any dishwashing equipment must be Energy Star rated. Hot water equipment performance. So there's a table in here with different equations for figuring out the rated efficiency that is required based on the size of and type of the hot water heater. There's a couple new types that have been added in here: a tabletop 3-foot cabinet sized heaters, grid enabled electric heaters, and heat pumps. Heat pump water heaters now have their own section called out here. And then there's gas storage and gas instantaneous water heaters listed as well. Any circulation pumps on your hot water systems, they need to have some sort of control on them to turn the pumps down or turn them off when hot water isn't required. So that's either a time switch during certain times of the day, maybe outside of business hours, to just turn the circulation pumps off, or a aquastat to determine what the return water temperature is to the pump, and whether you can turn the pump down or off based on that. And in any healthcare facilities, if they need to meet ASHRAE standard 188 for health reasons, then they do not need to follow these pump control requirements. So that was it for that section. I think I'll just keep moving on to this one. This is electrical power and lighting systems. So there are quite a few control requirements for lighting systems in buildings. For occupancy controls, they're required in a bunch of different types of spaces, all listed here. And these occupancy controls must be able to turn the lights off after detecting 20 minutes of unoccupancy. There are specific occupancy control functions for warehouses. In warehouses, you don't need to do full, you're not required to do full shut off of the lights, but you must do at least 50% power reduction with based on unoccupancy. And each aisleway must be of the warehouse must be controlled separately and also separate from the other open spaces within the warehouse. And in open offices, each occupancy sensor can only cover 600 square feet of area, and again, be able to turn off fully after at least 20 minutes of unoccupancy. Another new section for controls in this code is for egress lighting. So that's lighting that would typically be on at all times. So egress lighting must be able to do at least 50% power reduction after 15 minutes of unoccupancy. You do not need to do this if your egress areas are 50% less than the LPD power allowance. If the total amount of egress lighting is less than 0.02 watts per square foot of your entire building area, or if there's other requirements based on fire codes where you need to not adjust the light level of the egress lighting. So time switch controls are required for any areas that are not required to have occupancy sensors. So anything that wasn't listed previously. Time switch controls must be programmed to have 7-day and holiday scheduling. They must have backup programming in case the power goes out, manual override for up to 2 hours, and up to 5,000 square feet of area per override switch. If time switch controls are not required in areas that are doing patient care, any shops or labs, or anywhere else where safety could be affected by the lights turning off. Light reduction controls, so any areas that have the time switch controls also need to have manual controls for the occupants to reduce the light levels down at least 50%, if not more. But you do not need to include that in areas that are following daylight requirements, which I'll go over right after this. Any small spaces with just one 50-watt fixture or less, any space less than 0.3 watts per square foot, or corridors, equipment rooms, lobbies, or electrical mechanical rooms do not need light reduction switch controls. Daylight controls are required in spaces that have over 150 watts of fixtures within a daylight zone, whether that be top or side. So whether that be from skylights or windows. I'll go into how to calculate those daylight zones in a little bit. Exceptions are healthcare facilities with patient care, the first floor of any A2, which is restaurant type buildings, or merchandise shopping buildings. They do not need daylighting controls. Or if the LPD is less than 35% of what is allowed in the code. Daylight controls you must control the side light and top light zones separately. You have to be able to dim continuously down to at least 15% output in offices, classrooms, labs, and libraries. And then if there's enough light, you must be able to shut off the lights completely. You must be able to control the different orientations of the building, whether it's north, south, east, or west facing, those different areas of the building separately. 3-minute time delay prevents cycling. If you've got like a cloud that passes over quickly, so you don't have the lights dimming up and down very quickly. Each sensor can only control 2,500 square feet, and you can have a manual override, but only to reduce the light levels, not to increase the light levels. So to calculate the daylight zone from windows, what you would do is the lateral projection out is this distance h, which is the height from the floor to the top of that window. So you would take that height and project that laterally out from the base of the window, and then you would, looking at the plan view, you would take 2 feet on either side of that window and project that out as well. So any light fixture that is within that daylight zone would need the daylighting controls associated with it. And if you have skylights, for each skylight you take 70% of the ceiling height and project that all around the outside of the skylight down onto the ground. Again, looking at the plan view, whatever fixtures you have within that daylight zone would need to be have the daylighting controls associated with them for that single skylight. And there are a couple other tables in the code for rooftop monitors and clear story windows. I just didn't include those in here. So what do you include in your lighting power density calculation? So any general lighting fixtures that are in the building at all times need to be included. If you happen to have any screw-in lamps, you would include those. If you've got track lighting, it can be a little trickier, but you use either the wattage of all the lamps and fixtures on the track lights or 8 watts per linear foot of all the track mounting sections that you have. That's just because it's a flexible type of lighting, so there's no knowing if more lights could be added down the road. So that 8 watts per linear foot is usually the higher amount. So that's typically what you'd end up using in the lighting power density calculation. And there's certain areas that are not included in the lighting power density calculation are dwelling and sleeping units. They just need to have 90% of their fixtures must be high efficacy. Any task lighting for plant growth and maintenance, that's a new one that is now exempt from the code. and any emergency and exit lighting does not need to be included in the LPD calculation. So there's two different methods for the lighting power density calculation. There's the building area and space by space. So this is the building area method. I've just listed some of the most common building types that we see in Vermont, and what the associated, those numbers in there are watts per square foot that are allowed. I've got the previous version of the code and the new version of the code listed in here, and the amount that has changed on the right. Overall, based on all the building types, it's about a 25% reduction in allowable watts per square foot for building area. And for space by space, there's a whole lot of these listed in the code. Again, I just chose some of the more common ones here. And again, we've got the reduction on the right side. Some spaces didn't change at all, like corridors. Some changed around 25%, conference rooms, offices, and some changed even more, say warehouses, housing large items went down 40%, electrical mechanical rooms 55%. If you average out all the different spaces, it again is about a 25% reduction overall, but it depends on what spaces you are looking at particularly. If you're doing a space by space calculation, you're allowed to add in some additional lighting power in retail areas. So if there are 4 different types of retail areas listed. Area 2 is for large vehicles and sporting goods. Retail area 3 is for furniture, clothing, cosmetics, and area 4 is for small items like jewelry and crystals and china. So you are allowed to, for all your retail areas, have an additional allowance of 1,000 watts, and then you add in the area of the 4 types of retail areas and multiply that by these values of watts per square foot. You can add that all together, and that's plus the 1,000 watts, and that's the amount of additional light and power that you can have in retail areas. So moving on to exterior lighting, there were 4, but now there's 3 exterior zones that you must determine which one your building is within before you find out what the requirements are. So zone 3 is those are like Vermont's largest cities and downtowns with the most commercial commercial type of areas. The most common that we see in Vermont is zone 2. That's sort of a mix of residential and light commercial areas. And then zone 1 are sort of, there's not a lot of development there. It's pretty rural or state forests. Sometimes some ski areas are within that if they're up in the state forest land. So depending on which zone the building is in, 1, 2, or 3, you start off with a base site allowance of either 250, 300, or 375 watts. And then you move down through different types of exterior areas that can be that could be illuminated. So if you've got parking lots and drives, if you've got walkways, stairways, any dining areas, those are all allocated a certain watts per square foot or watts per linear foot that you will add together, and that is what is allowed, and then you compare that to what is actually being installed. And this is the rest of the table, just some other types of areas that you could include. Overall, this is about 50% less allowable wattage than the previous code. So moving on to a new section here. So electric vehicle charging stations, there's now a requirement based on the number of parking spaces that a commercial building has for how many electric vehicle charging stations it needs. There's a table on the next page, and based on those numbers, when you're first constructing the building, you must install at least 50% of the required charging stations, and then at least pre-wire the remaining spaces for future fit up of charging stations. You've got to label the parking spots as EV use only. You got to designate that. And there's level 1, level 2, and DC fast charge requirements that you can choose between. If you're only going to do level 2 or DC fast chargers, you would combine the requirements of the level 1 and level 2s together. So we'll go on to that table. So what you've got here is based on your building occupancy type on the left-hand column and the number of parking spaces along the top. You've got less than 25 parking spaces, there's one option. And if you have 25 or more parking spaces, there is an option A and an option B to choose between. So I'm going to go through a quick example here to see if it makes some more sense. So if you have a hotel, which is group R1 with 100 parking spaces, looking at the different options, option A and option B. Option A states that there are no level 1s, level 1 chargers required, and 2% of parking spots must have level 2. So 2% of 100 is 2 level 2 chargers. Again, you only need to actually install 50% of those. So you would need to install one level 2 and pre-wire the other level 2 charger. And if you looked at option B, that states you need 1% of the parking spaces to be level 1 and just a total of 10 level 2 chargers. So again, you only need to install 50% of what's required, but you need to round up the whole number. So you actually need to install the one level 1 charger and 5 of the level 2s, and then pre-wire the remaining 5 level 2 chargers for future installation. So it really depends on the building type and the number of parking spaces on how many chargers are required. That's what I had for the electric and lighting sections. Bryn, can you let me know if there's any questions there before I move on?
Nope. You're all set to keep on rolling.
All right, thank you. So moving on, this is a fairly detailed section. It's been updated from the old version of the code, additional efficiency package options. So after all the standard requirements of the code, there's this last section that states that each new building needs to have 6 total credits of all the options that I'm going to go through. There's 10 options. If it's a tenant leased space, you only need to do 3 of the requirements. And this is based on the building occupancy type of the commercial building. There's some certain ones listed, and there's an all other groups. If 65% or more of your building is not all within one of the other listed groups, you would use that one. So, as I said, you need to get 6 credits, and there's 10 different ways to get there. So the first option is if you had more efficient HVAC equipment. Here you've got your building occupancy type. You've got R1, which is hotels, motels, R2, apartments and dorms, businesses and offices, E is schools, education facilities, merchandise buildings, and then all other. So that's how it's formatted for all of these options. So if you had 15% more efficient HVAC equipment based on those 12 performance tables, if 90% of your equipment was can be found in those tables and they all are 15% or more efficient, then you can claim the number of credits here based on your building type. The second option is reduced lighting power. There's two options within this. If you had a 10% reduction from the from the LPD values, or the second option is a 20% reduction in the LPD values, then you can claim these associated credits based on the building type. The third option is enhanced lighting controls. So if 90% of your fixtures have continuous dimming, each fixture is individually addressable, you've got daylight sensors controlling a maximum number of fixtures, a digital control system that can do load shedding, reconfiguring the occupant and daylighting sensors, have individual control within an open office, and a full sequence of operations document, then you could claim, for certain building types, you can claim these credits. On-site renewable energy. So if you use either, so these listed sources, solar, wind, landfill gas, biogas, biomass, or geothermal heat, if you size this renewable energy system based on the square footage of conditioned space for your building, it's listed here both in kBTU per year and kilowatt hours per year, depending on what type of renewable energy system you're going to install. It's the same value, just two different ways to see it. So if you install a system that is based on that size, you can claim these numbers of credits. If you have a dedicated 100% outdoor air system that's serving 90% of your conditioned floor space, you follow the ASHRAE 62.1 ventilation requirements for all of those spaces, and you have energy recovery built into that outdoor air system, then you can claim these associated credits. Service water heating. So for certain types of buildings that have pretty high water usages, you can see here the residential types of buildings, and also I1 is hospitals and nursing homes, A2 is restaurants, A3 is health clubs and spas, and F are could be laundry facilities. You've got three different options that you could choose here. So the first one is load fraction. So if 60% of the hot water for that building is provided by either waste heat recovery or a renewable heating energy system, then you could claim those credits on the top table. The second option is high performance hot water equipment. So if the efficiency is bumped up to 95% for all your hot water heating equipment, you can claim those savings. And if you have heat pump equipment, it needs to have a performance rating of 3.0 COP, and the air that heat pump is using to transfer heat cannot be pulled from within a conditioned space. It's got to be pulled from the outside or some air that would otherwise be exhausted from the building. The seventh option is advanced envelope performance. So if the thermal envelope of the building is basically all around 15% better than the code requirements, you can claim these savings. And that's based on the UA method. So the U values of that are stated in the code multiplied by the area of those different envelope components. Eighth option is reduced air infiltration. So if you test your building and it meets 0.25 CFM per square foot, that's an improvement from 0.30 CFM per square foot. That is the standard requirement. Then you can claim these credits. And again, you need to get up to 6 total. So some of these get you pretty close to there in one go. Commercial kitchen appliances. So if you've got a commercial kitchen that serves at least 5 meals a week, All of these types of equipment would need to be Energy Star rated. Fryers, hot holding cabinets, steam cookers, dishwashers, griddles, and ovens. If all of those are Energy Star rated, then you could claim these credits. And the last option for the additional efficiency package is controlled receptacles. So plugs in say like your office building. So at least 50% of all your electrical receptacles need to be controlled in offices, conference rooms, and classrooms. You can have either like your top plug be controlled and the bottom one not be, or have two different plugs within a foot of each other that look different, so you can tell which ones are controlled and which ones are not, because there's certain pieces of equipment that need to be on 24/7 that do not need to be controlled. And these are controlled by either an occupancy sensor, so they would shut power off after 20 minutes of unoccupancy, or some time of day scheduling during, say, business hours, where those receptacles would, the power would shut off outside of business hours. And this is only available for businesses and school and education buildings. All right, finished with that section, just got a couple left. I'm going to assume we're good here. I'm going to keep moving on. So the next section is building commissioning. So buildings that need to be commissioned are, it's no longer a square footage requirement building size, it's now a system capacity size requirement that will require commissioning. So any cooling system in a building that is 480,000 BTU per hour or greater, you would need to commission that system. And if you have space, if you've got heating and hot water, if the combined capacities of those systems is 600,000 BTU per hour or more, then it would require commissioning. And for the requirements for commissioning, you've got to have a pretty detailed commissioning plan, which is laid out in the code. You've got to do air and water balancing on those systems in the building, functional performance testing on your HVAC equipment, those controls, any economizers, and also on light fixtures and their controls. There's a commissioning report that needs to be generated after this process, and you must include documentation, all the balancing reports, construction drawings with notes in there, and operations and maintenance report for the building owner. So the last section of the code just states, how does the commercial energy code relate to existing buildings? I didn't have it in here, but if you've got an addition, then that obviously needs to comply with the energy code requirements because that's just a new section. But if you've got alterations to an existing building, basically you can't, the building cannot be less code compliant than it was after the alteration. So the code states certain areas that do not need to be brought up to code. If you're making these alterations, if you're installing storm windows, putting film on single pane windows, if you're exposing any cavities and they're already filled with insulation, that's fine. If you're any cavities that are not being exposed, you don't need to bring those up to code levels. If you're replacing an already existing electric resistance unit, that's okay to do. Roof recover doesn't need to be brought up to code, or air barrier roof recovering if you're not touching the remainder of the envelope for the building. And if you've got to do any of these repairs, you don't need to bring these components up to code. Glass only replacements, roof repairs, same thing, the air barrier of a roof if you're not touching the rest of the building envelope. Vestibule on an existing door, you can't remove a vestibule if there already was one, and bulb and ballast replacement, so long that the light and power density values are the same afterwards. And if you got a change of occupancy for a commercial building, then if the change in occupancy is going to increase the demand of fuel and or electric in the building, then it theoretically is supposed to be brought up to the new commercial energy requirements. And the lighting for your new occupancy type should match that of what you're changing to. So you would go to the tables for the new building type. And that is all I've got. Again, this is the disclaimer from earlier. And if you've got any questions about the code, I know this was a pretty, like I said, a pretty brief overview of what I thought the big issues are, or what you should know. You can reach out to me or the Energy Code Assistance Center, which I also may reply to if you contact us. So thank you for joining, and I will pause now to see if there's any quick questions before we wrap up.
Great presentation, Charlie. Thank you so much. I think we are all set with this at this point in time. The recording will be available online, and if as Charlie mentioned, if there are requests for a hard copy of the commercial energy building standards code book or for the residential code book, you can reach out to the Energy Code Assistance Center and see if we have any available that we can mail to you. So thank you so much, Charlie. It was a great presentation, and we look forward to connecting with folks soon.
All right, great. Thanks, everyone. Take care.
Have a great day.